Good morning, viewers. My name is Fahad once again, and I'm here for mechanical Draughting N4. And today I wanted us to look at cams. I wanted us to look at cams and answer at least a question. And our question for today is on page 97 of your textbook, and it goes: draw according to scale 1:1 a full profile of a cam disc with a knife edge follower using the following data. So we have camshaft diameter 30 millimeters, stroke height 48 millimeters, minimum diameter 46 millimeters, performance upwards from 0 to 180 degrees according to simple harmonic motion. Then it dwells for from 180 degrees to 270 degrees. Then the performance downwards from 270 degrees to 360 degrees according to constant velocity. And the rotation is in clockwise. Now, the question requires us to show the displacement diagram. And we are saying the displacement diagram must be drawn on the left-hand side of the cam profile. This is very important. They are saying do not insert any measurements. So no dimension is required. Then they say we must show all the construction lines. Now, let us collect our data so we can tackle these questions. Head on. So, looking at the shaft diameter, that is the diameter of the shaft from where the cam was cut. So that is the diameter. And here is our data. So we are having our diameter 30, we are having our stroke height 48, our minimum diameter 46, from 0 to 180 degrees, performance upwards, simple harmonic motion, 180 degrees to 270, it is dwelling, so there is no lift, no fall, 270 to 360, constant velocity, and according to the rotation is clockwise. So, let us take this one on. So we will start by the displacement diagram. And that is our stroke height, which is 48. And like we said from the start, we divide this height by 6. So we can have 6 divisions. And if we divide that by 6, 48 divided by 6 gives us 8. So we'll have our 0, we will have our 8, first one, then we will have 16, then we will have 24, we'll have 24 plus 8 will have 32, 32 plus 8 will have 40, and 40 plus 8 will have 48. Yeah. So on the vertical, we divide that height into 6 sections. 1, 2, 3, 4, 5, 6. Then on the horizontal, that's where we are having our displacement. This is where we are having our displacement, and it is in degrees. The rotation. So we are having the first. We divide this horizontal section into 1 centimeter. So we are having the first as 30 degrees, 60 degrees, 90 degrees. You will have your mid 180 and the last 360. Please, I'm doing this just because I'm trying to cover up for the time, but please divide it up to the end. Don't jump sections like I'm doing now. So have each centimeter for 10 degrees, for 30 degrees up to the end. And then you start with your performance. They are saying the first performance upwards is a simple harmonic motion. Simple harmonic motion from 0 to 180. So the whole of this section. The whole of this section, our cam will be performing an upward stroke and according to simple harmonic motion. We said that for simple harmonic motion, we draw a half revolution at that end. A half revolution at that end. And the way we do it is, this is the middle of our height. So we will put our compass there. We open our compass to either the 0 mark or the 48 mark. And then we will make that arc. And after making that arc, we divide this into 30, 30, 30. So we will have our 30, we will have 30 then, 60, 90, until we have 180 at that point. Okay? So we are having, that's our 0, 30, 60, 90, plus 30, 120, plus 30, 150, plus 30, 180. Now, if you may realize, we are having these points now. We are having these points. This point here. This point becomes our first. So we are having our first point, which is this is 0 mark here. Then we are having our second point, which is the line of 30 where it meets the arc and where it crosses the 30. So these are the other lines. Let me actually draw them. And this is our first point. Then we are having this 60 mark where it touches the arc. We project it there. Where it crosses the 60 becomes our second point. Then our third point. Then our fourth point. Then our fifth point. Then our sixth point. Until they are all covered. And we will join those points. We will join those points from the 180 to the 0. Remember, our motion is from 0 degrees to 180. So we join these points that have been formed up to the 180 point and at the highest, and we will have a curve of that nature. Actually, it is supposed to be a smooth curve. It is a smooth curve. Okay? And that curve will be determined by how accurate you have been when dividing these sections. Now, the second motion says it is dwelling from 180 degrees to 270 degrees. It's dwelling, which means there is no upward or downward. Let's say this is our 270. Please, like I said, divide your sections correctly and accurately and do not jump any measurements so that we are able to follow each other. So, that is our 270 degrees mark, that point. And we are saying it is dwelling from 180 degrees to 270. No upward, no downward. That's the dwell. Now, after the dwell at 270, it says down there that from 270 to 360 degrees, it is going a downward movement according to constant velocity. And we know that a constant velocity is a straight line. So we will have a straight line. Please draw it with a straight ruler such that you get it as straight as possible. It's not straight for me here because I'm using a free hand. So our displacement diagram is done. Now we have to now draw the profile, and they said they want the displacement diagram on the left hand side of the displacement diagram. So we draw our profile. Remember the method that I taught you on how to draw accurately and correctly the profile? Is you look at the shaft diameter, then you look at the minimum diameter. Now, that's one. Two, you must always make sure that your profile does not go, your work doesn't go into the displacement diagram. But how do you determine the distance between the displacement diagram and where to start your profile? I gave you a method, I gave you a formula, but for today, let us consider, I don't know if we have enough space here, but I'm sure it should. It should, but try to do it accurately on your drawing boards. We are having the minimum diameter as 46, and we are having the shaft diameter as 30 millimeters. So if we decide to draw our profile there, and we are saying the minimum diameter, so that's our diameter for the shaft. The diameter of the shaft, and normally I said we hatch it, so we section it. And remember the sectioning, these sectional lines should touch both ends of that circle. It shouldn't be lines that are ending nowhere. They must touch. And when we are marking, we do mark that as well. So you make sure, please make sure that those lines touch all the ends of the circle. And the minimum diameter, 46, so that should come up to this line, the 46. Now, that is your starting point. Now, your starting point is at 0, which is that mark. And normally, I always advise that you divide this into the same divisions that you have on your horizontal here. So you divide 30, 60, 90, 120, 120, 150, 180, 210, 240, 270, 300, 330, 360. So you have a 0 mark and a 360. 30, 60, 90, 210, 240, no, 110, 140, 150, this is 150, this is 180, this is the 210, this is the 240, this is the 270, this is the 300, this is the 330, and 360. So we look at those points. Our first point, of course, our first point is there on the 0. The second point, we project that line. And then with your compass, you will have your point there. The second point where it crosses the 60, you project that point there, and then you mark where it crosses the 60. You go to the next point, project it to that 90, and then you mark all your points. Mark all your points as they come, and then you join those points with a small curve. You join those points that you have marked. You join those points that you have marked with a smooth curve. And that is our curve. So you realize that it starts at 0 and ends at 0. It starts at 0 and ends at 0. Let us recap quickly. We said you draw your stroke height on the vertical and your displacement on the horizontal. You divide the stroke height by 6, so you can get 6 divisions. After getting the 6 divisions, then you divide 30 degrees each section on the horizontal, and then you start with your motions. It says from 0 to 180, from 0 to 180, simple harmonic motion. That's the curve that we did. We started by making up that half revolution. We divided it into these divisions that we have on the horizontal, and then we drew lines that corresponds with these divisions to get our points, and we mapped all the points and joined them with a straight curve. From 180 degrees to 270, we had a dwell, and we said in a dwell we don't have a fall or a rise. The curve remains. If it was in a closed mode, it remains closed. If it was in an open mode, it remains open. So no upward or downward movement. And then from 270 degrees to 360, we had the constant velocity, which is our straight line from the 270 to 360 degrees, straight line downwards. Right? Now, for the profile, we said these are the two things you look at. You look at the minimum, the shaft diameter, and you look at the minimum height, the minimum diameter that you are given. And we said that the minimum diameter gives you the lowest point, what you would call the bottom dead center. BDC. That is the lowest. If it was your piston, that is the lowest it will go. Okay? So that's where you have your minimum. So that's your minimum diameter. Okay? So minimum diameter, that one, we measured it. Shaft diameter is that one that we have sectioned, and then you start plotting these points here. Let me just note them with the stars so that you are able to see until the end. So you take these points onto this vertical line, you mark them, put your compass there, your compass in place, you mark them where the 30 meets the 30, you put it on the 30, where it meets with the 60, that point there on the 60, you bring this point onto the vertical with your compass, bring it to the 60, the one for 90, that point you bring it, project it to the vertical line there, project it to the vertical line, bring your compass, project that line to the 90, and mark, and you do that for all the points. For all the points. You will realize that from 180 to 270, there was no rise, there was no fall. Which means it will remain in the same. There will not be a rise or a fall even on your cam profile. And I think with that, you should be able actually to answer any question that may come to you from this chapter, which is the cams. This question normally carries 15 marks. Normally carries 15 marks. The most important parts that you need to know or you need to master in this chapter is the correct understanding. The correct understanding of the question. And this should be well done if you can collect your data correctly and understand it from the question. And this is the simple way you can always do. I've always advised my learners that actually, even if you did not get the whole question, but you are able to summarize this way, if you can just use this example. 0 to 180 degrees, you see the arrows pointing up, meaning upward motion, and then summarize the motion this way, so that you don't constantly go to the question back and forth, like I always say. That question paper is always for 4 hours. But I've seen people who have even requested for more than 8 hours to answer that question paper. It all starts here, by you not being able to capture the data from the questions. I don't want to prolong this video. In case you have any questions, please do not hesitate to come back to me on WhatsApp or email. You may send me your questions on WhatsApp 074 065 9784, or you can send me an email on Fahad at jpcollege.co.za, and I will be able to answer all your questions pertaining to this chapter. Thank you.